All right, great. Well, thank you, everyone. Good morning, good afternoon, wherever you're located at in the Americas region. It's great of you to join today. I appreciate it. My name is John Blevins. I'm the Americas Solution Partner Program Manager here at Keysight, and I'm excited to present and offer this webinar to those of you that have signed up for us to show really what it looks like when two companies work together on an incredible joint solution. So thank you for joining the Redefining 5G millimeter wave semiconductor testing webinar. I'm going to do a couple of introductions and then I will turn it over to our speakers to get this webinar kicked off. On the webinar today from the Keysight side, we have Brian McCarver. He is the field sales engineer here based in Southern California. We have from the Marvin Test side, we have Jim Frayne. He is the director of sales. Both Brian and Jim will be handling any chat questions that might be coming through, any questions that you might have during the webinar. They'll be handling those and responding accordingly. The presenters for today, we have Sam Cusano. He's an application development engineer here at Keysight, based up in the San Francisco Bay Area. And then we have John Samanchek, who is the Director of Marketing at Marvin Test. He'll also be a presenter based here in Southern California. So at this point, what I'd like to do is I'd like to go ahead and turn it over to our presenters. Thanks again, everybody, for joining, and I hope you enjoy the webinar.
Thanks, John. So again, my name is Sam Cusano, and with me we have John Samanchek. So today's webinar titled Redefining 5G millimeter wave device semiconductor testing. This is our agenda today. So in the first half, I will present my part, which includes the target device and challenges. And also, I'm going to quickly go through our new PXI VNA solution to measure effectively for the device under the test. And also, we have Marvin Test Solutions agenda, including millimeter wave test requirement, system architecture, calibration, test performance, and extending test system capabilities.
Sam,
and lastly,
you're yes. Not sharing your screen.
Oh.
Thank you.
Excuse me, I thought I was sharing my screen. In fact, I was sharing 5 minutes ago. How about now? Am I sharing my screen?
Sure.
Yeah, I see it.
Sorry for the technical issue, and let me continue. All right, so here's our agenda for today. Let me go through my part. Testing next generation devices. So we have highly integrated beamformer integrated chips and front-end modules, and that requires wide variety of tests. And flexible and precise hardware is needed to make the accurate measurement for the real-world performance of the active components. And in that test, we use modulated signal for the measurement that involves specialized test instruments. That's the condition where we are for the next generation devices when we look at 5G. And this is the typical target component example for Beamforma Ic or front-end module that is used in the 5G, especially for the FR2 applications. So we're talking about beamforming that includes the antenna module described right here that makes a beam. And in order to make beam, we need to have multiple antennas, and in order to control the amplitude and phase for the antennas, we use something called Beamforma Ic. Let me turn on my pointer, right? Beamforma Ic. And this is the very simple example of the Beamforma Ic. You have multiple TX and RX or TRX module that has the phase control and amplitude control with the power amplifier in the front. And as you can see, it has multi-direction, meaning transmitter side and receiver side, or multi-band, for example, 28 gig and 39 gig, multi-channels. In this example, I am showing 4 channels per device. And sometimes people make just front-end module that has higher performance PA and also LNA. But in this case, same thing, this is the multi-direction device. And the other example is the high power amplifier. Especially for the satellite communication, they handle really high power. And in that case, DUT requires booster amplifier. And typically, we need to have external configuration or external coupler to make accurate measurement as the S-parameter test. And sometimes people use noise power ratio measurement or NPR measurement to make the distortion characteristics of the DUT under modulated signal condition. And the biggest challenge for this type of device is simply just because of the many different types of the test. For example, if you look at the transmitter side, you're measuring gain phase and visual, just a linear parameter, or spurs, harmonics, compression, pass profile. In addition to that, people measure modulation distortion analysis or nonlinear characteristics under modulated stimulus condition. That includes EVM or LCP and NPR. Also, on the receiver side, we measure gain phase visual, same thing for the linear parameter, and also spur, intermodulation distortion, plus noise figure. And the remarkable thing is that this is two-directional device. So we need to make different directions to measure. And multiple parameters of active devices test. So traditionally, people were testing the device at first with the vector network analyzer with the CW signal using, S-parameters test, compression, IP3, and noise figure. Then put the device to the different station to make modulated signal condition test, including LCPR, NPR, and EVM. So they need to have two different stations to make one device. But the thing we are going to propose now is that what we say vector component analyzer concept that includes all of these measurements into one station that measures CW and modulated test signal test with one connection. And we have two different types of the platform today using PNX with the modulated source. And those type of the platform is suited for R&D and design verification test that requires external wideband source for the signal generation. And because of the nature of the single connection and multiple testing, it's very easy to make the test and very accurate because of the vector correction. And today we can have amplifiers and frequency conversion components as a DUT. In addition, today we have PXI-based solution with the vector adapter. Basically, we can do the same thing as what we can do with this. But it requires external components such as couplers, and we only support a non-frequency conversion device like amplifier. But we are using the same measurement science to make the measurement, and it's scalable and compact PXI-based test system. And this is the vector component analyzer, a little bit of the high-level overview. It's excellent accuracy because of the vector corrected measurement and also lower cost. We do not need big PNX boxed solution. It's about half of price compared to the standalone benchtop instrument. And it's higher throughput, which is ideal for the production test. And because of the nature of the single connection, multiple measurement, we can make both CW and modulated source measurement with this. And within the PXI solution, we have two different types. And one is the external VFG that measures, the CW and modulated source. And the other solution is the vector adapter solution. So we are basically taking the subset of the feature from the modulated source into one PXI module to make CW as well as modulated source measurement. And this integrates a vector adapter in the compact PXI form factor. And this solution supports from 22 to 44 gigahertz. So it can cover most of the 5G FO2 frequency. And this is a kind of little bit detailed view of the PXI vector adapter and VCA solution. We have 3 VNA PXI version VNA at here, as well as vector adapter. And also we have AWG right here. And with these modules, we can have 2 ports with modulated stimulus condition measurement. So let's look at VNA at first. So this is existing product for about 2 years already. We have PXI platform VNA that supports up to 53 gigahertz. And we have VNA and also receiver module to make external configuration test set. And VNA firmware combines physical test ports defined as the logical port. And it's the most flexible setup to optimize to be the optimized performance for modulation distortion analysis or EVM analysis or high power. So in this example, I am showing VNA module and also receiver module. And I have port 1 and port 2 source and 2 receivers. With this configuration, I can make external test set configuration using directional coupler at here. And by using external coupler, I can have booster amplifier to have higher power to stimulate your device. And this is inside of the VNA module and also receiver module. In the VNA module, this is fully integrated 2-port reflectorometer. As you can see, I have integrated bidirectional coupler right here and also here. And I have RF source for port 1 and also port 2. So it's fully integrated 2-port VNA. And by this module by itself, you can make 2-port S parameter measurement up to 53 gigahertz. Whereas receiver module, we have very simplified configuration at here. We have only receiver 1 and receiver 2, no RF source. We offer lower cost to support this receiver module, and we have limited frequency from 26 to 53, but we can make direct receiver access configuration using external coupler. Like I shown in the previous slide, we can set external configuration with the boost amplifier. And using this module, we can make modulation distortion measurement. So this is just showing the configuration of the DRA for high power measurement. Right here, I have a full configured reflectometer VNA at here, and also receiver module at here. And in this example, I can do boost amplifier and also directional coupler at here to make external configuration for port 1 and standard configuration for port 2. And for DRA configuration on port 1 and port 2, we are using full VNA at here and 2 receiver modules. In that way, I have directional coupler here and also here on the port 2 to make 2-port configurable test set or external coupler test set. In addition to that, we released Vector Adapter, which provides CW or modulated signal. And in our application, we are leveraging our CW signal from the PXI VNA to provide CW and also modulated source. And in order to make the modulated source, we are using AWG 9336 existing PXI AWG module to make IQ conversion. And by using this circuit, we can have either CW or modulated signal. And S parameter frequency is up to 53 gigahertz because just we are using CW signal here. Today, our modulated signal frequency is limited up to 44 gigahertz. And we support up to 1.08 gigahertz of the bandwidth. And we have fast setting time with the solid state switches attenuator. So we have very first switching here and here to have to switch between CW and also modulated signal. And of course, with this circuit, I have a single connection measurement. Okay, so I am showing the measurement example of this configuration. I have gain or small signal S21 measurement and also S11 matching measurement, as well as EVM and ACP measurement using modulation distortion application. And I am measuring one of the amplifier that has about 10 dB of the gain. We are looking at 4% of the EVM and ACP of about minus 29. So within the one connection, we can make CW S parameter measurement and also figure of merits measurement for modulation condition. Like I said, this is really scalable multi-port configurations. Because of the nature of the PXI, we can basically multiply the ports. And I am showing just an example of the 8-port VNA using 4 2-port VNA modules. And also, we can have 8 receivers using 4 receiver modules. And this is really flexible. You can configure as you want. So with that, I'm going to summarize my part. So using PXI VCA concept, we can have very good accuracy for the measurement, including EVM measurement with the vector correction, repeatable and correlated result with the proven PNA X solution. I think I forgot to mention that all of the measurement science behind the PXI module is basically same as what we are using on the PNA X measurement. So if you are using PNA X in your R&D or design verification stage, you can directly leverage your measurement into production using PXI VNA. And lower cost solution. So if you look at the production solution, it is typically difficult to use very expensive box type instrument. But the nature of the PXI, you can have lower cost in the solution as well as a scalable and flexible solution. And with the PXI VNA, we can have CW as well as modulated signal condition testing now. And high throughput. Compared to the boxed solution, we are optimizing the system to be more production oriented, meaning more faster measurement speed or overhead time for the test setup. So we can provide higher throughput. And of course, we are providing single connection for the CW normal VNA measurement, CW measurement, as well as modulated measurement. So this is ideal for mass production. So following the session, we are going to invite Marvin and they are using Keysight PXI VNA into their test system to provide those value propositions. So with that, I'm going to close my presentation and turn it over to Don from Marvin. Marvin, are you ready?
Yes, I am. Can you hear me?
Yes.
Very good. Great. Thanks, Sam. That's some great information. And the Keysight VNAs definitely deliver superior measurement performance for these applications. I'm John Szymanczyk. I was a test engineer for many years, and now I'm Director of Marketing for Marvin Test Solutions. And now we're going to continue our discussion by shifting more to a system level perspective. As we know, 5G test in the sub 6 gigahertz range is significantly less complicated than for mmWave devices. Whether you're dealing with instrumentation, cabling, different types of interconnects. Therefore, as we move into the mmWave test arena, many aspects of tests become more complicated, and this impacts almost every aspect of the test system, including our calibration approach. Sam, next slide, please. Basic interconnects and cablings are almost an afterthought when you're dealing with many lower frequency applications. But when we move into the mmWave frequencies, there are many factors that contribute to the measurement error, and each has to be carefully considered, addressed, and quantified. For example, as we consider the measurement path from the VNA instrumentation to the device under test, we find there's going to be multiple interconnects, the associated cables, the blind mate interfaces, and the impact from the load board itself. So in the production test environment, each of these contributes to the test system error budget, whether it's from the associated insertion losses, signal reflections, as Sam was talking about, the repeatability of the blind mate interfaces, or cable performance. And it's interesting when you think of just about cable and bend radiuses of cable, you can buy two different systems, and if the manufacturer is not paying careful attention, you can route cables differently, and you can have tighter bend radiuses. And at these high frequencies, that will definitely impact system-to-system performance. And that's one of the things we're really careful about when we put these systems together. Then moving forward, Sam. So before we move into the actual test system details, we'd like to take a quick look at the type of performance data and information that manufacturers expect when testing and characterizing these mmWave semiconductor devices. The performance tests shown really aren't much of a surprise when dealing with these devices, and they include insertion and return loss, the variable gain amplifier performance across the entire operating range of interest, and power gain and phase performance measurements. In some instances, manufacturers are also concerned with characterizing the noise figure to understand the noise output of the receiver and the adjacent channel power ratio to understand, the power contained in a specified channel relative to total carrier power. Then moving on. Next slide, Sam. So we can translate these performance requirements that we just saw into the types of measurements and control signals that must be supplied by the test system itself. As discussed earlier, the Keysight VNA is utilized to perform the S parameter measurements as well as the gain and phase measurement. Basic communication device under test typically occurs using a SPI or I2C interface, and this is performed utilizing the dynamic digital I/O card with basic register reads and writes. The digital interface is also capable of performing contact tests prior to applying power to semiconductor devices. And this is done by leveraging the per pin parametric measurement unit functionality on these dynamic digital cards. And that's a key aspect so that we don't damage the device when we power it up for the first time or after we move fixtures and so forth. Moving on. Now we're going to take a quick look. Sam, if you could move forward, please. Now we're going to take a quick look at why automating these types of measurements are critical as we move into the production environment. This image you're looking at is a laboratory setup, and While the use of laboratory instrumentation in a manual setup will certainly yield acceptable results, we've got to be aware of issues associated with this when we move into the production environment. Speed obviously is one, but the long-term repeatability and the potential for damage from handling cables that are removed and reconnected repeatedly is definitely a concern. And as I mentioned, test speed and not to minimize footprint will definitely be unacceptable with this type of configuration for most people in production environments. And we're going to see how we can address that in just a few slides here. And moving on. As we move into the automated test arena, we're going to see that MTS has designed and delivered mmWave semiconductor device test solutions, leveraging an open architecture design that simplifies expansion and instrumentation updates, and with the base configuration being able to support up to 20 VNA ports. And this is leveraging the Keysight instrumentation, of course. The system level performance up to 44 gigahertz has been validated in multiple production environments with independent non-multiplex multi-site performance up to 53 gigahertz. And this is simply possible by selecting the different model numbers of VNAs. Careful selection of cabling, interconnects, and blind mate interfaces ensures repeatable test performance out to the device under test. And as we're going to see in just a minute, test times with this type of setup, and Sam touched upon this as well, far exceed what you would expect to see in a box setup, and it certainly is an industry-leading performance with the Genesis Semi systems. These solutions also support the most common probers and handlers, making sure and allowing reuse of assets that manufacturers already have on the production floor. Next slide, Sam. So test system flexibility and being able to easily update instrumentation and capabilities is a key concern that we hear from many in the semiconductor test community, and this essentially covers the test community as a whole. This is a real concern. The PXI platform, or for those of you who aren't familiar with it, it's PCI extensions for instrumentation, is utilized because the modular instrumentation architecture delivers a PC-based solution that incorporates high-performance instrumentation with the benefits of an open industry standard. There's many advantages over proprietary designs with using these PXI solutions, including scalability, reduced footprint, lower power requirements, and one of the key things as you move forward in the life cycle of products is obsolescence management of your test system itself. Using modular instruments also allows capabilities to be expanded or upgraded to higher frequencies, like we just discussed, going from 44 gigahertz to 53 gigahertz, with really minimal effort, especially compared to some of the proprietary systems out there. And the highly integrated nature of the PXI platform also delivers advantages in system throughput, bandwidth, and synchronization, and resulting test times are significantly faster than other solutions. And we're going to take a look at a chart in just a few minutes that really drives that aspect of it home. Next slide, Sam. Now we're going to take a quick look at the instrumentation and interfaces that comprise the Genesis Semi mmWave solutions. As we already discovered, that the Keysight VNA instrumentation is at the heart of the RF measurement subsystem. It delivers exceptional measurement performance and, just as importantly, repeatability. And the source measure units have been incorporated to deliver precise multi-channel power with the ability to force and accurately measure, or in some cases even limit current. And this is an essential requirement for this type of test. Manufacturers often need to understand current draw during different operational conditions, including reset, sleep, idle, and while operating the devices at maximum limits. In the multi-channel SMU, it's ideal for this type of application because a single instrument can deliver isolated, independent operation for up to 4 different domains. Sam, next slide, please. The digital interfaces are primarily used to communicate and control the semiconductor devices, typically with SPI or I2C interfaces. The dynamic digital card is ideal for this type of application, and it can easily be programmed to communicate with these as well as other interfaces. The per pin parametric measurement unit, or PMU as we commonly refer to it, is typically used to verify connectivity prior to applying power to semiconductor devices. And this, of course, is to minimize the potential for damage as we apply the power. And the load board and daughter board IDs are also verified utilizing these types of digital interfaces. Next slide, Sam. Now sometimes the critical nature a chassis plays in a system can be overlooked, especially when we're talking about something as exciting as VNA measurements to 53 gigahertz, and then we start talking about, oh, it's a chassis. But the chassis is definitely a critical link in the system. Scaling the Genesis Semi up to 20 VNA channels means incorporating 5 different VNA instruments, additional SMUs, possibility of different digital interfaces, and all of these place additional power and, just as importantly, cooling demands on the overall system. The smart chassis delivers the high power and airflow needed for these types of applications, and it also includes smart functionality so that during the test process, you can actually monitor voltage and temperature limits and levels while the system is in use. And we can't forget that with any automated test system, software definitely plays a critical role. In the Genesis Semi, we're utilizing MTS's AT-Easy Test Executive and Development Studio to provide the interface to all the instrumentation, and the easy-to-use text-based programming environment simplifies and speeds manufacturer software development activities. And it's real familiar. As you go through school, you work with different types of software programming languages, Visual Basic and so forth, and it's very similar to that. The test executive, or test sequencer, as a lot of people refer to it as, also provides a well-defined test execution structure, debugging tools, and the ability to generate test documentation. And that's also critical in many different applications. It is definitely the most cybersecure integrated executive and development environment available. And just as a side note, it's currently being used in many military and aerospace applications just for this reason. And we're going to talk a little bit more in just a moment about the suite of semiconductor utilities that is also part of this solution. Next slide, Sam. So calibration is a key part of the system level performance. If we can't do an accurate calibration, then we really can't successfully test in a production environment. So system level calibration is critical, and there's no question that the millimeter wave calibration is no exception. The measurement path includes many sources of error, and we've touched upon some of these. It can result from interconnects, my cabling, the blind mate interfaces. And this all has to be quantified to accurately isolate and measure the performance of my device under test. Once the measurement path is characterized, the linear error can be removed from the test system to isolate that DUT. The most accurate approach, and that adopted in the Genesis Semi systems, includes a multi-step process to isolate the device under test. First, we're going to calibrate the RF path up to the DUT load board using traditional methods. There's nothing really unique about that. But then moving forward, test coupons are used to characterize the DUT board path from the connector to the device and then back to the connector. From this, touch tone data is generated, and I assume most people are familiar with that, but it's essentially just an ASCII file that contains frequency values and pairs of values for the magnitude and phase for each of the S parameters at the various frequency points. Then this is all combined to provide an overall system calibration solution and to accurately and repeatedly characterize the signal path to and from the device interface. This is a critical aspect of the test system, and really it's important that that this is done very, very succinctly. Next slide, Sam. So this is just to show a brief comparison, if you will, when we look at a commercial proprietary system versus a system based upon an open architecture design, such as the Genesis Semi. Typically, your commercial proprietary, or as some people like to refer to them as big iron testers, they tend to be much higher cost. The support structure can be really rigid as far as getting support, and if you're looking for some type of customization, that can really be a challenge. And the same can be said when obsolescence management comes into play years down the road. Now, from the standpoint of an open architecture system, such as Genesis Semi, and Sam talked about the cost aspects of just the VNA portion of it. It's much more cost effective. The support tools are readily accessible from the standpoint of the instrumentation of the various pieces because it is an open solution. Modularity certainly supports customization. So down the road, let's say you need a different type of measurement put in place into the test system. Again, referring back to the chassis, if you have open slots in the chassis, it's a matter of inserting the new instrumentation and interfacing to it with software. So really, from the standpoint of customization, many of those activities can actually be handled by the manufacturer if they so choose. And then from the standpoint of obsolescence management, that's a real concern with any test system. We certainly don't want the test system to go obsolete while we're still in production for the various products that it's supporting. So from that standpoint, that there's a large and diverse supplier base out there and a lot of different alternatives from the standpoint of managing the life cycle of your test system. Next slide, Sam. Now, I have a colleague, and he loves to use the phrase, test time is king. So the faster the test time, the better. And if you take a look at this chart here, you're going to see there are significant advantages to the MTS system utilizing the Keysight VNAs over big iron competitive testers. Let's just take a look at the first one, for example. If we're looking at a 6-port single site test, our total test time is just over 13 seconds. Let's jump down to competitor B. What do we see there? That's an order of magnitude more, 132 seconds as compared to 13.3 seconds. Significant difference makes a huge difference in the production world. What about looking, for example, at doubling the ports? We're doing a 12-port configuration with a dual site test, 14.4 seconds. Nobody else in the industry comes close to these types of execution times. And keep in mind, we're achieving these type of test times and not sacrificing accuracy, calibration, or any of the other aspects that are critical to you receiving very accurate and complete data for analyzing and evaluating your production ICs. Next slide, please. And this is just to give you a brief view into some of the overall key performance characteristics that our customers have expressed as being very important to them. Vector correlated measurements, as Sam mentioned, are critical. And many of the competitive products out there don't have this capability. Same goes for gap-free measurements to 53 gigahertz.
You what?
In standard production test system, it's a 44 level. The open architecture is certainly critical. The ability to expand your ports is also.
Doing a webinar with Keysight.
Okay, you have some background noise. Could you please mute? I apologize. And then compatibility with the PNAX is Sam talked about. So if you're using a particular, or if you're using the PNAX in your laboratory, it utilizes the same measurement science as the VNA solutions that we incorporate in the MTS solution. Real quickly, just take a look at facility power, facility cooling. You can run standard 120 volts It's air cooled, you don't need any water cooling, and the installation time, and this has been validated at 3 different customer sites, installation time and running self-test is achieved in less than 1 hour. Pretty impressive. Next slide, Sam. Now we're going to take a look just briefly at what we refer to as Mtek, which is Marvin Test Expansion Kit. And this is for solution or for testers. For example, you may have a big iron tester and you need to upgrade the capabilities. So this is a PXI-based solution that offers modern instrumentation to extend the life and capabilities of these legacy semiconductor ATE systems. It can be readily integrated into legacy ATE platforms, and you can add, for example, customers come to us and they need to improve the speed on the digital interfaces or include capabilities, improve PMU capabilities, or analog test or RF test for that matter. We can incorporate the Keysight VNAs quite easily in here. It's a flexible solution and it's scalable, and it's specifically configured to address the range of test needs both for packaged as well as wafer test applications. And it's designed to support engineering and high volume production installations, and it's an ideal solution for extending the life of these various testers. This next slide then is a real nice graphic that shows an installation, and you can see that it's relatively straightforward from the standpoint that there are 2 cables involved. We have an interface going back to the host computer from the Mtek, and then we also have a cabled interface going to the load board that would address signals coming from the box, whether it be digital or our higher frequency RF measurements. So as far as if you're running into challenges and you have an existing test system on the floor and you just need to extend the capabilities, that this is a very nice solution. It's elegant and it's been tested and validated at multiple customer sites. So keep that in mind if you run into these roadblocks where you need to expand current capabilities. Then moving forward, Sam. Again, we talked briefly about the software tools, but we base the overall system level control and interfaces, GUIs, all those types of things, debugging tools are based on AT Easy, the Test Executive and Development Studio. And I think that the Test Executive is really a key part of this because you can set up and run tests quite easily in a very straightforward manner without a lot of difficulty in using very standardized and defined processes. IC Easy, it's a comprehensive software tool, and it incorporates the ability to do things like IV curves and SMU plots, both for DC and AC tests, and it also has quite a few translation tools involved if you already have existing installations that you need to address. And then Sam, last slide. So as a summary, there's no question these solutions have the highest throughput production test capabilities available in the industry. And as we saw, 13.3 seconds as opposed to 132 seconds, very, very impressive. Our open system architecture addresses things like obsolescence management and obsolescence concerns. We have exceptional RF measurement performance with the vector correlated capabilities, our gap-free performance, and the capability or the compatibility with the measurement science with our laboratory instrumentation that we're using with the PNAXs. Quick installation and executable execution capabilities, and the ability to leverage the PXI platform from the standpoint of expansion, enhancing functionality, as well as obsolescence management and control. So with that, I believe we have completed the main portion of our presentation, and now we'll be moving into the question and answer segment of today's presentation.
So hi, this is Brian McCarver. It looks like I got a couple questions that came through the chat. The first question is there any special fixtures required for mmWave production testing?
I'll take that, John. This is Jim Frank. Good question. Yeah, the fixturing millimeter wave architecture requires a little bit more performance-based, or a lot more performance-based capability on the fixtures. And there fortunately are companies that provide that. And so the answer to that question is yes, Brian.
Okay, and the second question is, will Marvin Test assist customers in the test fixture effort?
And yes, we have on our team, on the Marvin Test team, we didn't go through all the people who are on it, but a couple of our team members have 25 plus years experience in developing fixtures, and in the last 10, 15 years, performance millimeter wave fixtures up to 60 gigahertz. So we do have the experience and further the interface capability to things like production wafer probers like TEL P12 and Opus 3, and production device handlers like Seiko Epson and SRM, to just name a few. So we will work with the customer and with the providers of the fixtures and the interfaces to make sure it all works together with our system.
Great. I have another question. What's the availability of this tester at the OSATs?
Well, we'll be shipping our first system to Taiwan in about 3 months, rough figures. And so, you know, we're working with them now, and that'll be in Taiwan. We're also looking at installations in Malaysia. So I would say we're 3 months away.
Great, thanks. And another question just came in about any plans to move to higher frequencies, 70 to 80 gigahertz, to support like wireless backhaul or automotive radar?
Right. Well, our plan is to follow up. Go ahead.
Sorry, this is Sam. So for the PXI, yes, we are thinking or investigating to have PXI version of that frequency, but at this moment we don't have any of the the specific timeline for those products. Got Jim?
Yeah. Thanks, Sam. Yeah, I was just going to say we follow our partner, Brian. We follow Keysight on that, and so we do have the intentions of moving into higher frequencies, but we're following Keysight.
Great.
Okay, Brian, I'd like to make one more comment real quick about the fixturing. I just want to make it clear that from the standpoint of the MTS solution, which incorporates the DNA and all the other pieces, MTS would be the single point of contact, and MTS would be responsible for all the various aspects, and we can help with the integration with the various handlers and so forth to ensure that the customer has a very seamless and essentially easy approach to get these testers up and running on the production floor.
Great, thanks. Looks like those are all the questions so far. Yeah, if anyone has any other questions, just please chime in on chat. We can answer them.
Hey, Brian and everyone on the call here, I wanted to let you know, and I wanted to bring this up in my first announcement when I welcomed you all. Everyone attending this webinar today will receive a solution brief, a joint solution brief between Keysight and Marvin Test. You should be getting that probably in the next couple of weeks, but everyone that registered will be receiving that as part of a thank you for attending the event, and it's a great way to see the full solution in a nice 3 or 4 page document that will be that will kind of summarize what John and Sam talked about today.
Great, thanks. Looks like we have one more question here. What kind of sync triggering is available between the I/O card and the RF instrumentation?
Jim, you want to address that?
Oh, yeah, so let me go first. So our PXI VNA has standard I/O interface, including skip interface and also other digital I/O interface that talks with the other instrument.
So that's one of the advantages, and that is one of the advantages of utilizing the PXI platform, as well as you have very tight synchronization and handshaking capabilities between the various instruments in the chassis.
Great. I don't see any other questions that have come in through the chat.
Okay. All right. I guess, John, Sam, did you have anything else to add before we go ahead and begin the wrapping up process?
No, I just wanted to thank everyone for your time today and for attending the presentation. I hope you found the information useful. And as John said, we'll get that brief out. And if you have any questions, hopefully that'll help as well. And feel free to reach out and contact us for any follow-ups.
Same here. I don't have anything to add. And thank you for attending this session. And if you have any question, please contact us.
All right, thank you very much. I see these slides and recording will be made available to us.
Correct.
That is, yes, that is correct.
Okay, thank you.
All right, well, thank you, everybody. I appreciate it. Leslie, Jillian, and the Keysight team, Marvin team, thank you so much for putting this together. I appreciate it. Everybody have a good rest of your day.
Thank you.
Thank you. Bye-bye.
Bye.
Bye.